host for today's webinar on smarter hydronic specifications. Thanks so much for joining us today. We've got an exciting session ahead with practical insights, real-world data, and time for your questions. So please make sure you drop them in the Q&A box throughout the presentation, and we will make sure to address them at the very end. I'm pleased to introduce our speaker, Harold Hugendorn, HVAC Market Unit Manager at Alfa Laval. With deep expertise in hydronic systems, Harold will present smarter hydronic specs that perform, challenging conventional views on pressure drop and showing how data-driven design can reduce fouling, cut CAPEX, and improve long-term performance. With that, Harold, over to you.
Thank you very much, Davida. And also from my side, and welcome to this webinar today. Today, as the topic says, smarter hydronic specs that perform. And today we're going to talk about pressure drop. Our aim is to give you a better understanding the impact of a pressure drop in a plate heat exchanger as part of an hydronic system. Furthermore, we hope to give you enough information and arguments. If you specify a certain pressure drop in your specification, you are able to give the arguments why and how. So, the agenda of today, we take a short jump back to the temperatures as base of design. We will give you some idea about the challenges we have in the market trend for pressure drop. We talk about the current trends in the North America specifications, and we give you sort of insight why are we promoting increased pressure drop. And of course, operating heat exchangers with a high pressure drop. The end of the section, there will be, of course, room for question and answers. First, we start as a little bit of a backup, the relation between the LMTD and the service area of an heat exchanger. What we see in general that there is a base temperature approach of 2 Fahrenheit as a base in design. We just want to point out, even if you go half a Fahrenheit broader in the temperature approach, you can already save 40% of the surface defined. If you take it further, even to 3 Fahrenheit, you save another 10% in your surface. So the driver of heat recovery is the temperature approach you defined. The more efficient, the higher investment cost of a plate heat exchanger. And of course, everything under the wings of an AHRI certification. What we see, and I call it a burning platform, we see over the last years a trend in the specification by lowering the pressure drop. It goes lower and lower. And we try to create with this webinar the impact of such a low pressure drop in the heat exchanger in relation to the efficiency. We hope to break the habit. And we hope to create a question or discussion. Is it more sustainable to specify 1.5 psi or, for example, 3 psi in a heat exchanger? I think it's a major dilemma for most of the stakeholders in our hydronic industry, like engineer, consultants, designers, and at the end of the day, the end users. What we have done to get the data analyzed, we have, of course, a design and calculation program used by Alfa Laval as an organization, and of course, our network of partners as rep and distributors. We have seen a total volume of calculations more than 100,000 over the last 2 years. What we see of all those calculations that in 50% of the cases, 50% is less than 5 psi. If there is a specification, in this case, let's say it's defined as a design pressure drop of 3 psi, we can see an investment level of 41,000 euros or dollars. But we also know this is a quite opportunity and a nice one for the manufacturers, because if we are a little bit in a tolerance playing around, let's say we go to 4.3 psi, you see automatically that the investment level drops to 35. And Is it measurable, such a small tolerance of pressure drop? Depends on the installation and accuracy of the measurement equipment. But we also know that in many cases, besides the 100% design for the specification, we have the seasonal load. So that means that not over a running year, 100% of the capacity of the load is applicable. In this case, we have a 20-ton duty ahead of us with the same flows. As you can see, based on a 3 psi pressure drop, we have to add on more and more channels to cope with the specified 3 psi. If we look to the other alternative, in this example, 7 psi, we need less channels. So that means with a low pressure drop, the velocity in the channel is less. On the long run, it also means a higher chance on fouling of the system, less energy efficient, etc., and high maintenance cost. We are all aware that, of course, higher pressure drop means high running cost and maybe a larger pump. But is it that much? No. We can see from the evaluation CAPEX and OPEX that the breaking point or the cross point is already in the neighborhood starting from 7 psi. And of course, in the OPEX, costs for the maintenance of the heat exchanger are calculated, including the higher running cost of the pump. The maintenance cost of a plate heat exchanger is the opening, the cleaning, and of course the pressure testing at the end of the exercise. As you can see on the blue curve, it's the investment level of the heat exchanger. And with the low pressure drop, the investment level is quite high. It also means low pressure drop, low turbulence, etc. in the heat exchanger, less efficiency. So a more efficient heat exchanger will come out with a higher pressure drop. Fouling. Fouling will appear with a lower turbulence in the channel in combination with the lower pressure drop. It always starts at the end of the heat exchanger because that's the longest uh, space from entering at the connection. In this case, we see an heating loop where only a third of the package is used by in the duty from the heat exchanger. And it also appears and applies for every channel. If in the channel the fluid has the tendency always to choose for the shortest way. So if we have less turbulence with less velocity, the fluid will also choose the shortest way. Meanwhile, the fouling every channel will appear. It start growing till the end the heat exchanger is blocked. Meanwhile, your running cost of the pump will increase. Another important thing is to consider that we have, of course, not always the full capacity in the heat exchanger needed. What we know from measurement installations in the field on a global base and in close cooperation with pump manufacturers, we can see that in this example, 80% of the year, only 60% of the load is available and the flow is available. That means in this calculation program, instead of the design pressure drop of 3 psi, in the operational mode, it's only 1 psi. And hence again, that means lower velocity in the channel, reduction of the shear rate, and reduction of the heat transfer efficiency. If we look to a broader perspective and try to cover where are the dangerous area, well, in this case, we calculate on a 70% load of the year. That means in the 3 psi design mode, and we compare it with the dangerous field where it starts, we can already see that at a pressure drop of 1.4 psi as the official operational pressure drop, In a lot of the cases during operations, it starts getting tricky by means of fouling and a reduction of the efficiency of the heat exchanger. So if you increase the pressure drop, in this case 5.7 in the specification, that means in the operational mode, in certain cases, the field where you are obliged to get fouling problems and difficulties is getting much and much smaller. What we can see, of course, is that the pressure drop in combination with a higher investment for a pump, of course, has an enormous effect. We have created a booklet where we explain the whole situation with different pressure drops. And of course, if we go for a higher pressure drop, there are certain things we have to know as the basic. Higher pressure drop means less investment in heat exchanger because it gets smaller. But it also means a bit of a more investment in the pump and of course in the running cost. But as we said before in the certain slide, the crossing between COPEX and CAPEX and OPEX comes already on a fast rate like 7 psi area. This booklet will be shared with you after this webinar. One thing we should also take in consideration, in an heat exchanger, we have a self-cleaning effect. It's a shear stress over the plate and it's driven by the pressure drop, and we call it the tau value. And to give the tau value an, a definition, we talk about Pascal. And here we can see on the left the fouling grow rate in combination with the Pascal as shear stress, the tau value. And we can see that if we calculate units around the shear stress tau value of 50 Pa, that's a good rule of thumb. In our specifications, AHRI specifications, the shear stress, the tau rate will be defined and given in our specifications. Next one. Yes, one important thing we can tell from practice experience, if you have a partial flow in your duty of an heat exchanger, sometimes we see that the duty is separate and divided over, in this example, 5-plate heat exchangers. So depending on the duty, they regulate the system over 5 heat exchangers in this case. Well, it's obvious if you split the certain load over several heat exchanger, pro heat exchanger, the velocity, the pressure drop is rather low. And hence, there you have again the risk of faster fouling and of course reduce uh, the efficiency. So therefore, if you have split units to cover a certain duty, we highly recommend to use as less heat exchanger as possible. And in this case, the partial load drive only over 2-plate heat exchangers than over 5. So, of course, I think it's a major advantage that we can recognize this trend and try to manage it. So I call it calling the burning platform. And we all know we have certain objectives, like it consumes more pumping energy. It's true, but the thermal gain, the efficiency is much bigger, and the overall system is more efficient. And of course, your pumping cost will increase, but yes, not as much as most of us think. And of course, all practice doesn't take the modern performance into account. The heat exchanger range from Alfa Laval has developed themselves over the last years enormously. So you can't compare the old designs with the new designs. And as I said, we always put in a free PSI, but it's an yeah, a common behavior from ourselves, and let's be open for new criteria and new technologies. And yes, we want to avoid pressure drop. In general, that's true. But I think we should consider where we can optimize the pressure drop. And of course, in an optimal designed system, I think the pressure drop should be, I will call it consumed in the best places where we can consider it. And one of them is the heat exchanger. I also would like to take the opportunity to show you our recently renewed consultant engineering portal. I think at this stage in the modern times, our aim is to share all the knowledge we have to the engineering world. And of course, later on, there's possibility to see and where to get the information. But just to give you a short overview, the portal will have BIM files. We have the 2 and 3D drawings. We have a standard tender text driven by master spec. It's not specifying any brand. It's open for usage. It's downloadable. We have a lot of information regarding the frame, HRI, specification. The certification program is there. There's a knowledge bank that enables you to get specific information about plate heat exchangers and how to select and so on. And there is one important tool that I would like to point out. It's the PHE selects. It enables you to calculate the heat exchangers according to your designs. The applications is hey VSC, one phase. We have the copper brazed, we have the stainless steel range, and of course the gasketed heat exchangers falling under the and according to the HRI program. We have the applications and category over there, and it gives you the opportunity, if we refer it to this topic, you can make quite simply two designs with different pressure drops, and you can see online, direct, 24/7 hours a day, the impact of the difference in this example, of the pressure drop. So to give a little bit of a sum up and hopefully takeaways, um, we would really like to open the dialogue with building owners, maintenance engineers, and end users. Uh, why are we willing and hoping to increase pressure drops? Of course, the advantage of Alfa Laval new technology, the new plates, and of course the HRI certification program. Um, we also work closely together with the contractors in the market, and we always advise go for the higher pressure drop. At a longer run, it means lower cost. And I think the PHE and pump, they work closely together with the specified pressure drop in relation to also the operational pressure drop. And I think we should not be afraid of the pump operations. I know that all the pump manufacturers, they're developing themselves in regulation and so on. And I think it's a good opportunity. At the end of the day, we're all saving energy and creating more efficient systems. Um, Here are the useful links. We created some QR codes. I can give you, let's say, a minute to make some pictures. But after this webinar, we will send out information where you will receive another opportunity to use these QR codes. Um, and work with them, and hopefully you will use the selection tool to calculate plate heat exchangers, and of course the BIM files, and the tender specifications to make your life easy on a daily basis. All information is downloadable online, so hopefully the platforms create a tool platform for you with added value and make your life easier. So yeah, some reflections and questions. So
Thank you so much, Harold. We really appreciate your presentation today. Thank you all for your time. It is now time for the question and answer portion. You all will remain muted. However, if you have a question, please be sure to enter it into the chat at this time. Let's see what we have, Harold. Give me 1 second. All right. Let's start with first one I have. Can you explain how the PHE Select tool helps engineers optimize plate heat exchanger designs for different building applications?
yes, the platforms give you the possibility to calculate yourself with different temperatures, and even with different flows. I mean, we have water glycol in a different percentage of glycol. So it's an online tool where you can see for the optimal design of the heat exchanger and see the impact of the different pressure drop in forms of your capex.
Thank you for that, Harold. What are the benefits of specifying higher pressure drops in HVAC systems?
Higher pressure drops gave you initially a lower capex on the heat exchanger. It gives you somewhat a higher capex on the pump. Sometimes the pump is a little bit bigger. On the capex of the heat exchanger, it could mean it means less plates, but in certain circumstances, it also could mean a smaller heat exchanger. More, it also tells you the indication of your maintenance cost. Higher pressure drop will give you less maintenance cost because there's little or less chance on a fast fouling program. And that means opening up the unit, cleaning it, and testing it. And it gives you less increasing pump running cost due to the fact of higher pressure drops.
Thank you for that. I think to true back to that PHE Select tool question, could you
Yes,
explain a little more in detail about what shear stress is?
shear stress is a value that indicates the self-cleaning effect of a plate heat exchanger. And of course, it's driven by the pressure drop. If you pump over a rimpled plate, it gives you a certain uh, stress over the plate, and that force could be considered as the tau factor, the
Thank
stress,
you
the
very
Pascal.
much. Okay, next one is we need to use PHEs as a condenser in the refrigeration units. How can we
Yes,
select refrigerants in the PHE selector? We could not find them in the list.
that is correct. Refrigerants are two-phase applications, of course, and they are not available in PHE Select.
Thank you for that.
But
Wh-
we're happy to support you if you have a certain, um, let's say, a repetitive design for refrigeration system. I know that my colleagues of refrigeration team, they have also tools available. So if you contact me, I can forward you contact details to the colleagues who can evaluate how we can serve you the best.
Fantastic. When designing PHEX for heat pumps against a swimming pool, for example, which side should one start with, secondary or primary? That's always a bit confusing to us.
And when designing heat pumps against a swimming pool, for example. Huh. Ooh, that's an interesting question, and happy that you ask. Of course, one of the questions would be the heat pump. Is it air driven? Is it water driven? Is it part of a building system? Then we have, of course, the seasonal impact and the load impact. So it's also a little bit depending on the situation itself. But of course, I would be happy to have a deeper discussion one to one. There are some specific points we have to take in consideration. But absolutely an interesting question.
Yes, thank you. These are great questions. Does Alfa Laval recommend a level of filtration or strainer mesh sizes to reduce fouling?
Yes, we do. And of course, it's depending on the amount of fouling. We have different filter systems, but if we look to the HVAC market, and I'm not talking about taking in outside liquids like cooling water of a river, but we look in internal loops in a building. We have a possibility what we call a port filter, and that port filter is placed in the entry of the liquid. On the background there's a flange, so after a certain time you take the flange out and you just took the filter and you wash it out. And the filter mesh is depending on the channel width. And as a room of full of thumb, we take approximately 60% of the channel width of the pressing depth of the plate. So if you have a channel depth of 2 millimeters or 3 millimeters multiplied by zero point 0.6, then you know you mess with.
And then for just a quick follow-up to that, and then I'm going to go back to a question asked earlier. Even if using technical water, fouling occurs, or is it reduced somehow?
Well, from a practical point of view, normally people say to me, and I think the engineers are aware as well, closed loop are clean loops. But if we take, for example, a new building, there will be always fouling in the system by means of fouling produced during the production of the pipe systems. Um, and of course, we see also in renovation programs that older pipe systems there could be rust, and it will come out in the system. And the heat exchanger on itself is an excellent filter, so it will end up in the heat exchanger. So even with initially called clean systems in closed loops, there is a risk. Or a system engineer and contractor should give me a letter that he absolutely flashed the whole system and there is no chance on fouling. But practical wise, there's always fouling.
Thank you for that. Earlier we got a question around, earlier you recommended running multiple PHEs sequentially when going through varying loads. Would
Yeah.
this be done with motorized control valves?
Um, or in combination with frequency controller of the pumps. Yeah, you could define several messing points in your system, and then of course make the combination as you like with controlled valves or frequency controllers of the pumps. But it's depending on the system design you make and your set points. Is it temperature? Is it flow? Is it pressure drop? Etc.
Okay, thank you. Let's see. I have CIP system may be needed if a too large heat exchanger is installed and fouling occurs, but the CIP flow is usually much lower than normal flow and thus does not give turbulence in heat exchanger during cleaning and possibly not clean all width of the plate. Should cleaning be better with a high CIP flow?
Yes, absolutely. I mean, if you want to use CIP systems, you need an high flow to maximize the cleaning uh, impact. And furthermore, you should create a co-current flow with your CRP liquid to maximize um, the cleanness of the heat exchanger.
Okay. Will allowable nozzle load on the individual heat exchanger be visible from the online select tool?
No, but if you make a design and you send it to us, we can specify according to API 662 the allowable maximize nozzle loads.
Wonderful. Any additional questions? I have covered all that are currently in the chat, but certainly if you all have any more, we will wait just a minute to see if anyone else has any questions we can address with Harold at this time. All right. Well, thank you so much for your time, everyone. One question actually that we do have is, will you be running another one of these webinars in the future, Harold?
Yes, absolutely. We're going to run it on a regular base towards the future. As
Okay,
I
that
said,
is
our aim is to share experience, to share practical examples, and to share knowledge in the market with the major stakeholders.
okay. Well, that's fantastic. Well, thank you for that, Harold. Thank you, everybody, for joining us today. We do hope that you enjoyed the webinar and found the insights invaluable. Please keep an eye on your inbox, as you all will receive an email with the recording of this session, along with a short survey. Also, be sure to make sure you scan Harold's contact information on the screen if you'd like to connect or have any additional follow-up questions. We'd like to thank you again for your time today, and we look forward to seeing you at the next session. Thank you.
Thank you very much. Till next time.